Average speed versus instantaneous speed. If you have ever experienced traveling by an airplane, you have for sure felt the change in the speed of the airplane. During the taking off phase, you feel the airplane rushing upwards. Then, as it reaches the cruise altitude or the cruise phase, it attains a stable state. Finally, as it tends to land, it slows down until it reaches the ground of the airport. 1. Indicate whether the airplane moves at the same speed at different instants during the whole flight. Explain. So the airplane moves at different speeds at different instants during the whole flight. When it takes off, it increases its speed. When it is at the cruise altitude, it keeps a constant speed. And when it lands, it decreases the speed because we were given that it slows down. Now define an instantaneous speed. An instantaneous speed is the speed at which an object moves at a given instant of time. Then what do we have? Given that during a flight an airplane covers a total distance of 465 kilometers during the flight of 1 hour and a half. Indicate whether, according to this given, one is able to determine the instantaneous speeds at the different instants and explain. According to the given, we cannot determine the instantaneous speeds, but the average speed of the whole motion by dividing the total distance over the total duration for the whole motion. So V equals D over delta T, it's 465 kilometers over 1.5 hours, 310 kilometers per hour. So we don't know what is the speed of the airplane at each instant, at the initial instant of the first phase or at the final instant of the first phase and so on. But we can calculate the total distance and the total time so we can find the average speed. Now, application. Consider a race between two triathletes A and B. The race includes three phases: swimming, biking, and running. Triathlete A, triathlete B. The swimming distance is the same for both, the biking distance is the same for both, and the running distance is the same for both. So now the swimming time for A is 0.8 hours less than that of B, which is 1 hour, and the biking time for triathlete A is 3 hours greater than that of B, 2.5 hour, and the running time for a triathlete A is 1.2 hours greater than 1 hour for triathlete B. The question now is as follows. Calculate the average speed of each one of the two triathletes during the whole race. To calculate the average speed, we have to find the total distance covered during the whole race, which means including the swimming, the biking, and the running phases. So 3 kilometers plus 50 kilometers plus 12 kilometers is 65 kilometers. Now for the time, 0.8 hours plus 3 plus 1.2 for triathlete A. So this means that the average speed for triathlete A is D over delta T, 65 kilometers over 5 hours, 13 kilometers per hour. While for B, the total time is 1 plus 2.5 plus 1, it's 4.5 hours, less time. This means that he needed less time to cover the same distance. So 65 kilometers over 4.5 is 14.44 kilometers per hour. Now identify the athlete that finishes the race first. So athlete B finishes the race first because his average speed for the whole race is 14.44 kilometers per hour, which is greater than that of A, 13 kilometers per hour.